Hello everybody, so my topic is DHCP. So let's have a quick overview of DHCP. So earlier we used to configure IP address statically on each devices. In addition to configuring the static IP address, we need to configure the subnet mask, the DNS server, and the default gateway. IT admin had to make sure the IP addresses are unique and do not have any IP conflicts. But now we have a better and easier way to assign IP addresses dynamically. In addition to that, it can also assign a subnet mask, a default gateway, and a DNS server. So DHCP uses a client-server model, employs a connectionless service model using the user datagram protocol. So in this model, the client uses broadcast message as the latter has no idea what DHCP server's IP address is. Therefore, this type of connection uses UDP, which is unreliable and does not give assurance that the packet has reached the receiver. We make use of the UDP ports 67 and 68. So the first thing is to realize the range of IP addresses the DHCP server is allowed to give. Networking devices that need static IP addresses, we need to exclude them, or we need to make sure the IP address is outside of the scope. Now, DHCP has a finite IP address. So in order not to run out of IP addresses, DHCP leases the IP address for a limited amount of time. It depends on the environment. For example, at a coffee shop, we may give the lease time 1 day for a particular user. On a campus, it can be up to 1 hour. Or in an enterprise environment, it may be longer as we don't want to increase the network traffic with all the IP renewables. So UDP port number 67 is a destination port of a server, of a DHCP server, and a UDP port number 68 is used by the client. Now, let's talk a little bit about the DHCP operations. So DHCP operation falls into 4 phases: the server discovery, the IP lease offer, the IP lease request, and the IP lease acknowledgement. These stages are often abbreviated as DORA for discovery, offer, request, and acknowledgement. DHCP operation begins with clients broadcasting a request. If the client and server are on different subnets, then a DHCP helper or a DHCP relay agent may be used. In the DHCP discover, so the client broadcasts a request for a DHCP server using port 67. And then the second step, we have the DHCP offer. So the DHCP server on the network offers an address to the client. It reserves this IP address to the specific machine for a limited amount of time, called the lease time. And then the DHCP request. So this part, the client broadcasts a request to lease an address from one of the offering DHCP servers. And lastly, we have the DHCP acknowledgement. So the DHCP server now respond to the client to acknowledge the client and assign it any configured DHCP options and update its DHCP database. So let's dive into the operation. So now we'll be using my PC for demonstration purpose and see how the DHCP process operates. So first of all, let us check what is my IP address. So since I'm on Wi-Fi, so this particular IP address is given to me on the wireless LAN adapter. So I have this particular IP address with a subnet mask of 24/24, and my default gateway is my ISP modem, which is 192.168.1.1. Very well. So now, in order to demonstrate the DHCP process, so first of all, we need to release the IP address, the current IP address, which is 192.168.1.1.8. So let's do that and let's see what is happening over here. So I've already started the capture. As you can see, so we have the IP which is being released. So the source IP is 192.168.1.1.8. So this is my client. This is the client IP, and the destination would be the DHCP server, in this case, so 192.168.1.1, my ISP modem, right? Now, let us request for a new IP address. So we need to type the command ipconfig/renew. And as you already know, so we should be expecting 4 packets, which is discover, offer, request, acknowledgement. So here we are, discover, offer, request, acknowledgement. And we have the IP address of 192.168.1.118, this previous IP address with the subnet mask /24, right? And now let us see what happens when we renew the IP address, because we already have this particular IP address. Let us see what happens. So here you will observe that we no longer have the discover and offer packet when we already have an IP address. So it will only do the request and the acknowledgement. Okay, so now let's go dig deeper and see what are the particular information that interests us, right? So after the ipconfig release, my client, that is this PC, no longer has an IP address. So this explains the source being 0.0.0.0. And now when I'm requesting for a new IP address, so I'm discovering to see if there's a DHCP server on the network. So I broadcast the request. So it goes to the IP address 255.255.255.255. Now, remember, we said earlier, so UDP port 67 is used by the DHCP server and UDP port 68 is used by the client. So my PC is asking for a service, for a DHCP service to the DHCP server, so it will be using the port UDP 67, right? So next, the DHCP server, when it receives this particular request, so it checks on its range if whether it has IP address or not, and it leases the next available IP address in the pool. So now my server, which is 192.168.1.1, in my case, it is the ISP modem. So it will offer the IP address 192.168.1.118. So let's see the DHCP to option 53 here. So the message type is 1 for a discover packet. And for a DHCP offer packet, let's go to option 53. So the message type is 2. This is a way how we differentiate between the DHCP packet. So, and for requests, if we go to option 53, the message type is 3, and for acknowledgement, it's 5, right? So this is a way how we differentiate the value which differentiates a discover message and a request message or an acknowledgement message. Right, now what happens next? So if another thing to notice is that we have the same transaction ID over here. So F7 for this particular, the DORA process. So when we type ipconfig renew, so all of this refer to the same transaction ID. Okay, until we have the IP address. And then when we retype the ipconfig renew, it has to go through the two processes above, discover and offer. So these two are omitted, and we directly request the server, the DHCP server, the IP address for a new IP address. So it just requests, and the server gives a particular IP address back. Right, so these are the little information here. What else can we say? So together, so while after the IP address has been acknowledged, so we can see over here in option 51 we have the lease time, which is 1 day. So in my case it's 1 day, and the subnet mask is /24, and the router has this particular IP address. This would be my ISP modem, and we have the DNS server also configured as my default gateway and the router. So it is 192.168.1.1p. It's not too much in detail, but it's just simple so that it doesn't get too complicated for you to understand. So thank you very much for your time.